In this second lesson of Chapter 1 of the course of Basic Geometry, I present the relation between lines and planes of a plane geometry and definition of angles of various types. Between the topics are presented basic definitions, basic elements of a plane geometry, relations between lines and planes of plane geometry, definitions of angles and definition of their different types. In this first slide is presented the definition of angle. Using two concurrent straight segment lines, it is formed an angle, that is the opening between the two straight segment lines. This opening can be measured in degrees, radians, or grades. In geometry, the most widely used measure is represented by the degree symbol. For example, 90 degrees, that is equal to 100 degrees, or 3.1415 divided by 2 radians. The slide shows the value for 90 degrees. The point of intersection of the two segment lines that form the angle is called the vertex of the angle. If a point is marked on each of the segment lines, point A on a segment of a line and point B on the other segment of a line, the angle will be defined as angle AKB. The point of intersection is the point K. Then this angle has the vertex K. The use of the angle symbol before the three letters that define the angle is optional. The figure 1.4 presents the angle AKB that has the vertex K. In this second slide of this second lesson is presented the definition of the angle opposite by the vertex. It is possible to form angles using two concurrent straight lines. In this case, four angles are formed. In the slide is presented figure 1.5 that uses two concurrent lines that form four angles. These angles are called the angle AKB, angle AKC, angle CKD, angle DBK. The angles AKB and CKD are called angles opposite by the vertex and have the same magnitude. As these angles have the same value, they are said to be congruent. The same can be said of the AKC angles and the DKB angle. The angles opposite by the vertex and have the same value are angles congruents. By performing a rotation of one of the angles, an angle can be superimposed on the opposite angle. The figure 1.5 shows the four angles opposite by the vertex. This third slide in this second class continues to present other types of angles. Initially, the definition of a right angle is presented. Angle is called a right angle when composed of two perpendicular line segments, that is, two straight segment lines that has a degree of aperture equal to 90 degrees. In the vertex of a right angle, a small square with the symbol of degrees in the center is drawn. It is not necessary to present the value of 90 degrees that is presented in the figure. The figure 1.6 presents a right angle of 90 degrees. In the second part of the slide are presented the definition of complementary angles. A right angle is divided by a line segment forming two angles. In the case of figure 1.7, the angle AKB is divided by the line segment KC. Thus, you have two AKC and BKC angles. The addition of the values of the two angles has the value of 90 degrees. Thus, when the two adjacent angles have their value added and the result is 90 degrees, we say that these two angles are complementary. In this slide, other types of angles are still presented. The definition of supplementary angles is initially shown. If in a line we mark 2 points, for example E and F, and between these 2 points we mark the point of vertex K, and from the point K is drawn a line segment, this line segment divides the angle EKF in two angles, FKG and EKG. The addition of the values of these two angles has the value of 180 degrees. Thus, when two adjacent angles have their value added and the result is 180 degrees, we say that two angles are supplementary. The second part of this slide shows the definition of acute angle. By definition, acute angle is an angle having aperture of less than 90 degrees. In the case of figure 1.8, the angle JKE is acute angle. The third part of the slide shows the definition of obtuse angle. By definition, obtuse angle is an angle having aperture value greater than 90 degrees. In the case of figure 1.8, the angle FKG has a value greater than 90 degrees and therefore is obtuse angle. This slide shows the definition of a bisector of an angle and bisector of a line segment. In the first part of the slide, there is an angle AKB and the aligned segment KC divided the angle AKB into two angles of equal values, AKC and BKC. The segment of a line KC divided the angle into angles of equal value is called the bisector of the angle. The figure 1.9 shows the bisector of the angle KC. The second part of this slide shows a line KLDT, where 2 points A and B were writing. At a point that has the same distance from point A and B, the point K is drawn. At point K, it is drawn a line M, perpendicular to the line T. That is, it has an angle of 90 degrees with the line T. In line M, a point M was scored. Both the AKM angle and the BKM angle are right angles. That is, the AKM and BKM angles are supplementary. The line M, which is perpendicular to the line T and which necessarily passes through the midpoint between A and B, is called the perpendicular bisector of the straight line segment AB. The figure 1.10 shows the line M, and that is the bisector of the line segment AB. In this last slide of this second class of the plane geometry course, it's presented equivalence between the values of aperture of angles using various types of units of measurement. Thus, the value of 90 degrees is equal to value of P divided by 2 radians. The symbol P has a numerical value of 3.14159. Angle of 180 degrees corresponds to a value of P radians, 3.1459 radians. The second part of this slide presents the aforementioned concept of perpendicular lines. Two concurrent lines have a degree of aperture between them equal to 90 degrees, that is, 4 angles equal to 90 degrees. Those lines are said to be perpendicular one to each other. The figure 1.11 presents two perpendicular lines. Therefore, the AKG, AKB, BKC, and DKC angles have 9 degrees of aperture and they are 2 to 2 supplementary.